Hi everyone, today we're going to look at the law of conservation of energy. So here we have our roller coaster. The highest point here is where it has its maximum potential energy. Now total mechanical energy doesn't change between any point on this roller coaster. So here's our max potential energy, and then everything there, so let's say this is 20 joules, everything here will add up to 20 joules, potential and kinetic, potential and kinetic, potential and kinetic will always add up to the same amount. That's our total mechanical energy. So stuff we already know. We already know potential energy increases the higher an object is, so going up a hill, for example, and decreases the lower an object is, going down a hill. Okay, when an object goes up a hill, its velocity decreases, so it's going up, it's losing velocity, and its kinetic energy decreases. That kinetic energy is transformed to potential energy. And then vice versa, when an object goes down a hill, its velocity increases, which means its kinetic energy increases, and the potential energy is transformed to the kinetic energy. So we know that potential energy is based on height, and kinetic energy is based on velocity. So here's everything we know so far. So let's put that into different situations. So again, here's our roller coaster. Our law of conservation of energy states that energy may not be created nor destroyed. It can only be transformed from one type of energy to another. So the total sum of energies in any system does not change. Now, we could have a situation where there's friction, and then the friction converts some of the energy to heat energy. We're going to pretend that doesn't happen, even though we know it does. We're just going to go back and forth between potential and kinetic. So here's an example of a pendulum. So when a pendulum swings, it has a maximum height, it has its lowest height, minimum height, and then it swings back to its height again. A pendulum will never go higher than its starting height. It will lose energy due to friction in the air. Okay, so it will get lower and lower and eventually stop. But when we're looking at this, the highest point, okay, so here over on this side and on this side, that's the maximum potential energy. Then when it gets to its lowest point, that's what we call zero potential energy. We're basing it, that's our reference point for zero. So all of this potential energy has been transformed to kinetic energy. So let's say this was 20 joules of potential up here, and 0 joules of kinetic, hasn't started yet. Over here, it's 20 joules of potential and 0 of kinetic. And then at its lowest point, it's 20 joules of kinetic and 0 potential. Now, when it's halfway between each of these sides, half of the potential has been transformed to kinetic, so they're both 10 joules over there and over here. And then you could do that on any point. So if we could calculate the height and figure out, let's say this is 18 joules of potential. That means this 20 minus 18, 2 joules of that is now kinetic. And then here's just another example. Our total mechanical energy, our green line over here, never changes. The potential and the kinetic change back and forth, but they always add up to the total mechanical energy. And you'll notice over here, none of these loops are higher, or hills are higher than our highest point, because then it would not have enough energy to get to those heights. You always have to go with your total starting energy. And here's just one more example just spelled out. So we have the top of the hill. It has potential, right? Total amount is potential right now. No kinetic energy because it's not moving. We roll it down the hill. Now some of that potential is transformed to kinetic until it gets all the way to the bottom and all of it's kinetic. And we call this point zero potential energy with reference to our highest point. And then here's where some friction comes into play, slows down the ball, transforms it to heat energy, and now it's completely stopped, so both of them are zero. So now this system has been affected by energy. But from this point, and this point, 1, 2, and 3, your total mechanical energy always adds up to the same thing. So now for your assignment, you're going to look at this problem at the bottom, and you're just going to fill in what you think is going on for each of these. Remember your highest points, your highest potential energy, your lowest point, looks like J is the lowest point, lowest potential energy. And then kinetic energy is based on how fast it's going. So the lower it is on a hill, the more kinetic energy compared to different spots. Okay, let me know if you need any help with it.